You ever have a real shit job? The sort of job where the work's real hard, and it keeps stacking up. And the customers, they keep asking for more. They just don't stop complaining. Um, and then one day, someone says, "Hey, everything's going to change. Things are going to get way, way better." But the first thing you see is that there's a lot more work. And the work's weirder, and the customers are stranger and worse. Now, I've done a lot of hard jobs in my life. I've done jobs that people don't love, like stacking boxes in a warehouse or waiting tables or um, selling shoes. Now, jobs like that, the one thing I've learned is if you ever do one of them, the best part of it, the only part of it that ever gets you through is the people you're doing it with. But what if the people you're doing it with have also gotten real, real weird? Now, I'm going to talk about one of those jobs today, and I'm not talking about stacking boxes or selling shoes. I'm talking about one of the truly strangest jobs you can have today in this economy, which of course is being an open source maintainer in the age of AI slop. I'm Jeff, and this is Iterative Refinement. So howdy, I want to make sure you know as much about open source and where your software comes from before we dive into this whole big, messy topic. And so I'll begin with the basics here. I'm going to go right down to kindergarten level. Now, most of you probably already know that the vast majority of software you run around all the computers, all the devices you run, is not coming from places like Microsoft where someone is being paid to write that software for you. It's not coming from a company at all. It's coming from something like this. This is showing that little project that some random person in Nebraska has been thanklessly maintaining since 2003. And all of modern technology sitting on top. Classic picture. And we always bring this up in talks because this is the reality. This is actually how our software supply chain works. And so, shockingly, this works incredibly well, except for when it doesn't. Because sure, this guy may be getting a little bit of credit for people really love his little thing at the bottom of the stack. But what happens when things get wrong? There is a very famous exploit that happened in this place on a utility called XZ Utils, being maintained by one person who was so overworked that he was able to be socially engineered until an attacker was able to get the ability to merge commits and inject in some malware. Created a huge impact across the industry and is still one of the largest events in software security history because one guy just couldn't keep up with all of the work that was coming his way. Because of course he couldn't, because the majority of all of these people are not getting paid. 60% of open source maintainers are not getting paid. And that's probably a massive overestimate now that we consider the huge range of what are purely hobbyist projects. And this has always been true, but it's getting more extreme in terms of the risk factor of what happens here. You may have come across the recent incident of LiteLLM, which is a super popular Python library for managing LLM calls that got attacked and had a huge blast radius that basically disrupted every AI company around the world. And so AI is critical open source is critical infrastructure. It matters to all of us, right? We're all running this code. So what's changing now that really starts to make things even more extreme? Well, that, of course, is AI code. AI code is really, really increasing the rate of all the key metrics. And so the number of PRs are up, the sizes of those PRs are up, the number of issues per PR are also up, as are the security issues that are coming up in that. And so in general, all of the empirical data speaks to the software stability declining in the age of AI code. There may be new tools coming around the horizon, but that is the reality we're in today. And so people are getting really, really concerned about what the impact of this is on open source. You may have come across this post here from Jeff Geerling, who's really popular for his YouTube videos and for his commentary around open source, where he says that AI is destroying open source. So what do we mean when we say AI is destroying open source? It's helping us write code. It should be easier to be a solo developer. Well, some of the things that keep coming up are people talking about things like Daniel Sternberg and the curl bug bounty getting hit with a bunch of code slop spam. or TL Draw, shutting down all its external contributions. A lot of people have been having a really big reaction to all of this AI code coming their way. So where is that coming from? Well, because the AIs don't just wake up one morning and decide to write code. They don't wake up at all. So let's maybe kind of dive into where the most likely source of this stuff is. You may have come across this thing. I love this thing. It's a tremendously popular project. And in fact, I think is the most popular project on GitHub these days, which of course is openclaw. Now, openclaw is wild. Openclaw came out of nowhere, roughly November of last year. Started here in London, and then Peter grew it into something absolutely enormous. And with that growth has been really just a ton of commits, a ton of contributors, people just cranking away. I think last week, the week before, I was at ClawCon, and I heard Peter talking about maybe 1 million lines of code getting committed per week. This is a fantastic amount of code. Now, Peter and his friends in openclaw, they can run their project any way they want, and it's definitely working for them. People love openclaw. Oh my God, do they love openclaw. And that's because it allows them to build out whatever sort of AI agent that they want to do. But one of the really common uses that people have who are hobbyists in this space is that they want to build their credibility as developers. And so they use openclaw to do it. They basically have the AIs autonomously submit issues to PRs. And some of those issues are just really, really not good. And so that's the challenge that we're going to get into today, which is some people are writing good code. Some people are writing good code with AI coding tools. But a lot of people are throwing out a lot of PRs, and they're not all good. They're not all bad. But it's really, really hard to distinguish the difference between the two. And I really want to understand that. So, like, how do we get into that world where we can know who is a good contributor and who is not a good contributor? I don't have a perfect answer here, but I've started to work on this issue. And my solution for this that I've begun to build out is a system called Good Egg. So let's talk about what a good egg is and what a good egg does. So this is Good Egg. Good Egg is a project that I've executed over a series of rounds of work. Now, the original hypothesis about Good Egg was pretty simple. Was that all of us had been in open source for decades who were already running projects and knew what good behavior was. We could just write it down and we could systematize it. Some people have found out this idea of this sort of system of chain of trust where I vouch for you and then you vouch for me, and then we sort of build a web of people who are trustworthy. Mitchell Hashimoto's Vouch project is probably the biggest example of this, but there are others. This sounds like a bunch of extra work. I wanted to see if we could just simply automate this. So Good Egg begins with a very simple idea, which is let's see if we can understand from someone's behavior in open source through the commits that they merge. Are they in fact a good egg? Are they behaving the way that they should? And so there's a couple of different approaches that are taken here. So V1 is real complicated. It operates on a bipartite directed graph of user nodes to repo nodes and targeted PRs. I have all sorts of fun little math here. And it's basically saying, hey, what was this person contributing to? How recently did they contribute to it? What are some of the language multipliers? Does it matter if someone's contributing to something really niche like Zig or Nim versus something very mainstream like Python and JavaScript? And are they within the same language? As well as, are they just contributing to their own projects? Are they in fact just an open source maintainer of their own stuff? Well, all of this stuff really, really works to an extent. You can get some great results out of it. And so, I work through a bunch of different famous examples of different people at different levels of this. So, for example, you can just pull up this guy. This guy shows up in your repo. You think you should maybe accept his PR? Well, this is Jose Padlim. Super brilliant dude, creator of the Elixir language and a bunch of the libraries within the ecosystem. If he shows up on your PR, even if you're not necessarily writing Elixir, maybe you're writing Ruby, maybe you're writing Erlang, you should probably merge his stuff. And that shakes out statistically in the work itself. And so there's a lot of these really, really simple questions out here. But there's others. There are people like, well, what if you're the CEO of Vercel? And you stopped writing code a while back and you just jump back on and you have one little JavaScript fixed. Should we merge you as well? And work through all of these sort of different scenarios. And really the challenge here is not that the good people are actually incredibly simple to pull apart. They're super, super easy to identify. But the problem is all the good people look really good. They sort of compress at the top end. And so as a scoring methodology, what you end up having to find are the randos. And so like the people who are not big contributors to open source already, they don't have this huge track record. We want them to get lower scores, but we also don't want to block them out. And this gets into like why this is such a knotty and hard topic to figure out in open source maintenance. So we have to understand who you are and how we sort of dig into like how we can identify what to do when you are a new person. So one solution for this is to address some of your cold start concerns. This is actually the number one thing I heard when I launched GoodEgg from people was, it sounds like you're preventing people from becoming open source maintainers, that you're stopping them at the door. And I think that's entirely the opposite of my goal. And so the GoodEgg project continues to crank along. So in the V2, which is, the V1, depending on how you look at it, this is the approach to identifying really what's the difference here. So one is, let's actually just see fresh eggs. So these are people who just showed up. What I found was in actually trying to do the empirical research on this, should you merge this person or not when they don't have any history, is the short answer is you can't really know. You can do a little bit of bot filtering to say that this thing is likely a bot. But you can't really know with a new person. And so the most you can do is you can give an advisory score for a human to make a choice. But you can compute this and you can put it on the PR and say, hey, this person's pretty new to GitHub. They haven't merged a lot of stuff. Here's who they are. And you can leave that in the maintainer's hands. I think there's a lot more that needs to be done in terms of supporting the growth of new open source maintainers. And I'm going to have some work on that I'm going to discuss in the future. Another really interesting question, though, is all that stuff we said. So we said, hey, like there's all these criterion around what's the overlap in the language and what's the recency of their commits, and are they committing to their own repos? Well, does that actually work? Does that actually help us? Well, the short answer is not a lot, actually. It actually ends up giving us a whole bunch more computation to do, creates a whole bunch of weird, subtle business rules, and it's not actually more predictive than actually just merge rate, which is a really interesting outcome. And so in the diet work, what we landed on was really that all you need to understand to know if you should merge someone else's work is if other people are merging their work, just their merge rate, just merged divided by merged plus closed. That's it. Now, it may be helpful to know that when someone doesn't have much of a merge rate because they're brand new, that's what the fresh egg consideration gets you. But that actually gives you pretty much all the predictive power that seems to be in the data set. Another adventure down this road that is people have a lot of ideas about what bots are and what spammy behavior looks like within this code slop era, both from free LLM adversarial code injection of different sorts, but also during the LLM era as well. I tested a lot of different approaches for this, really trying to understand who GitHub is kicking out and why. The short answer is GitHub definitely doesn't expose sufficient data to really build a very good spam classifier unless you actually are at GitHub. And so the bad egg work actually says it's really, really hard to do so. You can maybe do a little bit of identifying things that list themselves as bots, like depend a bot and things like that. And you can scrub them out that way if you want to prevent automation. But that alone is not going to really help you. Finally, there's one more bit of work that I recently did that I think had a really surprisingly outcome, which was, well, what about the pocket veto? So this is the really interesting question of, do open source maintainers actually reject your PR when they think you've not done a good job? Well, the short answer is usually no. In fact, the statistics we've gathered in my research at my company have shown that the rate of abandoned PRs is increasing dramatically. And so typically these organizations that are getting hit with a ton of code slop, a ton of drive-by PRs with little consideration, they don't reject them at all. They just let them rot on the vine. And so I call this pocket vetoes or ghosting. And you would think that that sort of behavior and sort of seeing an accumulation of such things would give you a lot of predictive power for, is someone actually eventually going to merge this? Is someone who's piling up a bunch of junk going to look worse there? The short answer is it isn't actually more predictive of merge rate at this point in time. Did the research. I really wanted to have that sort of hollow egg merge in there that was just a more sophisticated scoring model, but it turns out that the problem is simpler than that. That actually merge rate alone is still the most predictive property behavior right now. But this is just a snapshot in time, and so I want to zoom us out to what's actually going on in the ecosystem because people are really actually very, very concerned about the state of open source, and so they're taking new approaches. So here's an example from the Probable team, which is the company behind scikit-learn, talking about all of the different acceptable use cases and unacceptable use cases emerging across the ecosystem. These are major projects that are saying, here's how you can and can't use code. And they're trying to explain the rules to themselves, to their projects, and then to aspiring contributors. Here's some work from Melissa at QuantScience, one of the companies that works on things like NumPy and Python. And this is a huge collection of open source AI policies across the ecosystem. A lot of Python stuff, but really giving you a sense of how everyone is digesting this and trying to determine the rules for themselves. I've talked to some of these people and dug into what's actually going on these days and how people are thinking about how to prevent this drive-by code slop problem beyond just, say, knowing who the person is and knowing who, in fact, is a good egg. And so one really interesting opportunity here is that you can just kind of explain the rules to an agent itself. This is from the Superpowers project that presumes now, because it is a tool that is used primarily by people doing agentic coding and other forms of AI code automation, that the person putting up the PR is a bot and need to be instructed as bot and to be, which means being incredibly prescriptive about things like the pull request format, the diligence that needs to be done, and the likelihood that they're going to get rejected. I love this headline number, 94% rejection rate. That's where you're starting things. And so this is framed really aggressively and really clearly that reputational risk on the human operator of the clanker here is really the thing that's at stake here. And from talking to this project, people are really, really changing their behaviors. The bots are doing much better, and the slop is going way down. This is something I see coming up time and time again in my research on this topic, in my attempt to build tools that help, is that if you are already an AI project helping people do automation on being able to generate new skills or write code with generative coding tools, that you're going to need to expect that people show up with exactly those tools. Here's an example from the Block project from Goose. And so in speaking to the leaders of this project, they were quite clear that the vast majority of code that got submitted from outside the building came from people who were using Goose to improve Goose in ways that they wanted to support their use cases. And so this is exactly what the project is for. But the contribution guidelines really need to be very clear about how a human should be operating Goose and the AI behind it to be able to do the responsible thing. And I think that's really what all of this comes down to. All of these conversations about tool chains and workflow, they're about social practices. They're about this really simple question, which is this person a good egg or not? Well, you'd have to crack it to find out. You actually have to look at the code. But there's a lot of these interesting approaches people are trying to do to narrow the amount of slop coming their way, to be less overwhelmed by the unconsidered drive-by PRs, which I think is an entirely reasonable response. And it's already working, that the clankers are incredibly steerable. And so what we're finding is that this brief moment of a slop spike is actually already self-correcting through the normal function of open source and people sharing best practices, sharing their contribution guidelines, and figuring out a way through together. And so I'll close out with just giving you one last look into how to check out my work in this respect. So the Good Egg project is open source. It's an extremely simple tool these days. You can use it as a Python library. You can install it via the GitHub Actions Marketplace. You can call it from our int by its MCP server. There's a lot of different ways to get involved there. But really, the core lesson here is that Good Egg ended up being a really interesting and educational and complicated journey, but taught me something really simple, which is that people in open source are more like each other than they are different, that good behavior is really consistent and ubiquitous, and that when things really, really change in the open source world, that we figure it out together as a community, which I think is a really exciting story. Now, that's not all that's going on in AI coding. Understanding the person and their behavior in these social dynamics is very much just about open source. I think there's more about understanding who's driving it, what they know, how to dig into what sort of expertise and judgment were applied to building each feature. And so I've been building that space as well. I'm going to tell you more about that next time. But for now, I will see you on the internet. Thanks very much, folks. Be well.